Hey, from West Virginia. Guess not. Well, what I do know is joke of the day is right here waiting for you because I know you've been waiting for it. So let's take it. Did you know that you can tell an ant's gender by putting it in water? Well, if it sinks, it's girl ant. If it floats, it's boy ant. Okay, well, let's float our way or sink our way into point plotting method for graphing equations in two variables. So we've looked at this idea of being able to determine solutions to equations. And that's important because when we look at the graph of an equation, in other words, the picture of an equation in two variables, that graph is the set of all points whose coordinates satisfy the equations. And that's very important because this idea of satisfying the equation, that means that they are solutions to the equation. So I'm going to go ahead and add that in there, solutions to the equation. So that is critically important to understand. A lot of people don't understand that about a graph. When you see the graph of the equation, that is a picture representation of not only all the points on the graph, but all the points whose coordinates, when you plug them back into the equation, they will create truth. I keep telling you guys, and I really do mean it, this math, it's all about truth. We want true statements. So everything that's on that graph will create a true statement. When you plug their coordinates, the x value and the y value, into that equation, it will create truth. Anything off of the graph will not create truth. Anything off of the graph will create false statements. So that is insanely important to understand. Those points on that graph, they are solutions to the equation. Anything off of the graph is not going to be a solution to the equation. So one of the ways, there are lots of ways to create that graph of the equation, but one of the best ways, one of the tried and true methods is what we call the point plotting method. And the point plotting method is exactly what it says. It is plotting points on the graph. And the way that you come up with the points on the graph is by coming up with those solutions to the equation. So that goes back to what we have just learned about how to generate solutions to the equation. And what that means is I'm going to come up with x values and plug them in here. I'm going to do that order of operations. It's going to spit y values out. That will give me ordered pairs, and I can put those ordered pairs on the graph. So basically it takes what we just learned how to do, generating those solutions to the equation. It just takes that and takes it one step further and says, hey, now let's take those ordered pairs, let's put them on the graph and let's connect the dots. So it's really just one more step to what we already know how to do. So in this, I'm told I want to graph the following equations. I'm going to put these two on the very same number line. So if I'm going to graph this first equation, what I need to do is I need to come up with some x values. I'm going to plug them into the 3x. That's going to spit out y values, and then that's going to give me a set of ordered pairs, x comma y, and I can put those ordered pairs on this graph. So like I said before, great idea to pick a couple of positive x values, a couple of negative x values. Let's go ahead and pick x to be 0 just to see what happens there. And that's going to give us a nice picture of the full 2D coordinate plane. So once again, like before, I'm not restricted. I'm not told what I have to choose. So I'm going to pick anything I want, making my life easy. So if I'm going to make my life easy, and I definitely want a 0, I'm going to pick a 1 and a 2. And you know what? I'm going to pick a -1 and a -2. So now what I'm going to do is take those numbers, I'm going to put them in here. 3 times -2 gives me a -6. So that gives me the ordered pair of -2, -6. And like I kept telling you guys before, order matters. This establishes a relationship. The relationship that was established right here because of this says that when the x is a -2, the y becomes a -6. That is the relationship. And so now I'm going to change it up and I'm going to say, well, what happens when the x is a -1? Well, 3 times -1 is -3. The relationship that has been established here says, okay, when the x is a -1, the y is a -3. And now I'm going to test out that 0. 3 times 0 is 0. So that means that when the x is a 0, the y comes up to also be a 0. And so now I'm going to test out the +1, toss it in there. 3 times 1 is 3. So the relationship that has been established here says, okay, when the x is a 1, the y is a 3. And now I'm going to do one more, and I'm going to test out that 2. And 3 times 2 is 6. So when the x is a 2, the y comes up as a 6. giving me 5 solutions to that equation. And remember, I've discussed before, there are a lot more than just those 5, but these are 5 of them, and I'm going to put those 5 on this graph because they also represent points on the graph. This is an ordered pair. The first coordinate is the x, the second coordinate is the y. So I've got the point -2, -6 that's going to sit right down here. And I've got the point -1, -3 that sits right down here. I've got the point 0, 0. I've got the point 1, 3. And I've got the point 2, 6 sitting right up here. And we can see that when we connect these, and I'm not very good at this, number one, I didn't put my points in the right spot. Number two, it really does help a whole lot if you have graph paper, which I don't have, because this is now looking like a curve, and it should not be a curve. It should be a straight line. But again, there's that plug for graph paper and a steady hand, which I don't have. But this represents the line y equals 3x. You need to understand that this y equals 3x, that equation is the name for the line. It's the name for all the points on this line. And the other thing that you need to understand, remember, these points on that line, those are the solutions to the equation. These are the points that when I plug them into this equation, when I plug in their x coordinates and their y coordinates, they will satisfy the equation. But the important thing to understand, it's not just this point, this point, this point, this point, and this point. It's everything in between them. So if I could figure out the coordinates for this point, now I'm not going to bother with it because I'm going to get some fractions here on the x, some fractions here on the y. But if I knew what the coordinates were for that, if I put that x coordinate here and its y coordinate here, that would create a true statement. So important that you understand that. Then if I pick a point right down here, now maybe that y coordinate is 1, but notice here the x coordinate again is going to be a fraction, and I don't really want to deal with that right now. But if I put that fractional x coordinate here, and I can guarantee that that fractional x coordinate is going to be a third. So when I take that 3 times 1/3, I will get a 1 for that y coordinate. So again, notice that it's everything in between here. And the arrow here says this line's going on forever, so it's all the points that are strung up through here. Arrow down here means it's going forever that way, so all the points strung down there. Everything on this line, when you plug their coordinates, the x coordinate and the y coordinate in here, will create truth. Everything off the line, everything down here, and everything up here, when I grab those coordinates and put it in there, it will not create truth. Test it out. Pick out this 3, 0 right here. If I put a 3 here and a 0 here, will that create truth? 3 times 3 is 9. 9 is definitely not 0. So you can see, no, this does not create truth. Pick something over here. Pick, for instance, this point up here. This is 0, 6. Well, if I put a 0 here, 3 times 0 is 0. 6 here, no, 0 and 6 are not the same. That does not create truth as well. So everything over here does not create truth. Everything over here does not create truth, but everything on the line creates truth. And that's why everything on the line is a solution to the equation. Again, crazy important that you understand that. So now let's continue with this idea and let's test this one out. So once again, I'm going to graph that using that point plotting method that says, okay, let's pick some values for x. We're going to put them into this equation. It will spit y values out. That will give me ordered pairs, x, y, and those will generate that graph for me. And again, I'm not told what to pick, so I can pick anything I want. I'm going to pick easy numbers. I do want to pick that 0, but I think I'll pick a 1 and a 2, or a -1 and a -2, and a +1 and a +2, because I'm going to make my life easy. So I'm going to put that -2 in there. Now notice this is a little bit different than we had before, because before it was just 3 times -2, we were done. But now I'm going to take that 3 times -2, get that -6, but now I'm going to subtract a 4 to get a -10. So that gives me the ordered pair -2, -10. And now I'm going to toss that -1 in there. And again, it changes it up from what we had before, because before when we did 3 times -1, we got -3. But now we're going to take that -3 and subtract 4 to get a -7, giving me the ordered pair -1, -7. Notice that we're getting different values for these y coordinates. Instead of a -6, we get a -10. Instead of a -3, we get a -7. That's because the relationships have changed. It's no longer just a 3x. Now it's take that 3x and subtract 4 from it. And that shifts all of these ordered pairs. And you're going to notice that on the graph here when we plot them on there. So now let's test out the 0, which previously we had just gotten a 0 out of that, but now take that 0 and subtract 4 to give us a -4. So that gives us the ordered pair 0, -4, not a positive 4. And so now let's test out the 1. 3 times 1 is 3, which is what we previously got, but we're going to subtract a 4 to get a -1, giving us 1, -1. And now let's test out the 2. Put a 2 in there. 3 times 2 is 6, and we had stopped there before, but now we're going to subtract a 4, giving us a 2, giving us the ordered pair 2, 2. And so now here are 5 solutions to this equation. Now when I plot these solutions on that graph, we get a -2. Now notice here I didn't extend this far enough. Here we go. Let's stretch this down a little bit because that's only -6. Here's -7, -8, -9. There's my -10. So -2, -10 is going to sit down here. And -1, -7, 2, 4, 6. Here's -1, -7. And 0, -4 is going to sit right here. 1, -1 is going to sit here. And 2, 2 is going to sit here. And once again, if I had graph paper, it would look so much better. And if I had a steady hand and a better eye, it would look so much better. But hopefully what you're noticing, yet again, a straight line. This is the representation of the equation y equals 3x minus 4. Once again, this is the name for this graph. And notice too that what happened was we took this graph and basically it looks like we shifted it this way, but we really didn't. We took this point that used to be a 6 and we moved it down to a 2. We shifted it down 4 units. We took here what used to be a 3. We have now moved it down to a -1. Once again, shifting it down 4 units. We took what here was a 0, shifted it down to a -4, again moving it down 4 units. We took what was a -3, shifted it down to a -7, shifting it down 4 units, and I bet that's what happened here. Take that -6, if we shift it down 4 units, yep, we get to a -10. So basically what happened is we took this equation, all their solutions, and we shifted them down 4 units, and notice that's what happened to this equation. We took what we started with, we subtracted 4, and that shifted everything down 4. Okay, so keep that in mind. Put a peg in that because we're going to see something similar to that happen in the next 2 examples. We're going to do the same thing in these 2 examples. We're going to graph the equations, and so once again, that's that point plotting method. So what I'm going to do in this first one is, just like before, I'm going to pick some values for x. I'm going to plug them in. It's going to spit y values out, and that's going to generate a set of ordered pairs for me, and I'll put those ordered pairs on the graph. And just like before, I'd like to see what happens over here, and I'd like to see what happens over here. So I'm going to pick a couple of positives, a couple of negatives, and I am going to pick that 0. And remember, we looked at an idea like this. I'm going to end up multiplying fractions. So I want to ensure that things are going to cancel in those diagonals. I'm not restricted as to what I choose for the x. I can pick anything I want. So I'm going to make my life easy. I'm going to pick numbers that will cancel with the 3. 3 will cancel, and any multiples of 3 will cancel. So for instance, a 3 will cancel and a 6 will cancel. I'm going to choose those. And then on the negative end of it, I'm going to pick a -3 and a -6. That ought to make my life easy. Because when I take that -6 and I multiply it to that -1/3, and I go canceling on those diagonals like I know I'm supposed to do, 3 goes into 3 once and a 6 twice, so I have a -1 times a -2, which is a +2, giving me the ordered pair -6, +2. Again, because of this relationship that was established. This relationship says when the x is a -6, the y comes out as a +2. So now let's test out that -3, toss it in there and see what happens. Once again, when we go to cancel on those diagonals, what's going to happen here is this 3 will cancel with this 3, so that I have a -1 times a -1, which is a +1, giving me the relationship -3, +1. Again, because of this relationship that was established, it says when the x is a -3, the y comes out as a 1. So now let's test that 0, toss it in there. Anything times 0 is 0, so we get a 0, 0 as that solution. And so now let's test out the 3, giving me -1/3 times 3. Once again, the beauty is the 3's are going to cancel because we're multiplying those fractions. And I get a -1 times a +1, which is a -1. And so that gives me the ordered pair 3, -1. And so now I'll test my 6. So when I put that 6 in there, 3 and 6 will cancel. 3 goes into 3 once, 3 goes into 6 twice. And so now I have a -1 times a +2, which is a -2, giving me the ordered pair 6, -2. So there are 5 solutions to the equation, and like we said before, there's many more, but I can put these 5 solutions on that graph. So a -6, 1, 2, 3, 4, 5, 6, +2 is going to sit right here, and a -3, +1 sits here, 0, 0, 3, -1 is here, and 2, 4, 6, -2 is here. Hopefully it's straight. It's supposed to be a straight line, but like I said, with me, you never know. If I don't have graph paper, it's hard telling. Looks pretty straight. That's pretty good. And it's supposed to be straight. So this is the equation, y equals -1/3 x. And again, this equation is the name for that line and all the points on that line. And like we said before, this point, this point, this point, this one, and this one. These are not the only solutions, because we do have solutions in between, we do have solutions that stretch beyond, we do have solutions that stretch above. But what are not solutions are anything up here and anything down here. So now, let's try this one out. And like we saw before, notice that we took this equation right here, and all we did was we said, let's just add 3 to it. So hopefully that idea of shifting things like we saw before will come into play here, but let's test it out. So let's go ahead and pick those values for x. Let's spit them in there, or put them in there to spit those y values out, giving us those ordered pairs. So let's go with, again, our -6, our -3, our 0, our 3, and our +6. And so when we put that -6 in there, whoops, I'm crowding things out, very sorry here. -1/3 x. Okay, so when we put that -6 in there, and we follow our order of operations, it says let's multiply first. And before, when we took that -3 times -6, we got a +2. Now we're going to take that +2 and add 3, and that's going to give us a 5. So because this new relationship is established, this was the previous relationship that said, okay, when x was a -2, y is going to come up as a 2. Now we've changed the relationship, and it says, wait a minute, this time when x is a -6, y comes up as a 5, not a 2. All right, let's test out that -3. Toss it in there, and like we had seen before, we said, okay, those 3's cancel out completely, and we get a -1 times -1 is a +1. That's what we came up before, but now we're going to take the +1 and add 3 to get a 4, establishing once again a new relationship. That instead of getting a -3, 1, because the relationship has been changed, now we're going to get -3, 4, because the new relationship. So now let's test out our 0, and anything times 0 is 0, which is what we got before, but now we're going to add a 3 to it to give us 0, 3. Again, used to be 0, 0, now it's 0, 3 because of the new relationship. And hopefully you are seeing the pattern that's coming up here. It does look like everything truly is being shifted up 3. We took a 2, we added 3 to get a 5. We took a 1, added 3 to get a 4. We took a 0, added 3 to get a 3. That does seem to be the pattern that's happening. So this ought to come up, when we add a 3, it ought to come up as a 2. The 3's will cancel here to get a -1. -1 plus 3, sure enough, is a 2. So we're going to get a 3, 2 out of that. And so finally, when we test out this 6, and I'm just going to put it over here because I'm running out of room. When we test out the 6, we really ought to come up with, when we add a 3 to that, we ought to come up with a 1. So let's see what happens. So 3 gives me 3 once, into 6 twice. 1 times, -1 times 2 is 2, like we got, or -2, like we got here. -2 plus 3, yep, it's a 1. Giving us that ordered pair of 6, 1. So here's those 5 solutions that we can put on the graph. And so -6, 5 is going to sit 2, 4, 5 right here. And -3, 4, 2, 4 is going to sit right here. And 0, 3 is right here. and 3, 2 is right here, and 6, 1 is going to sit right here. And again, if I had graph paper, it'd be so much better. I'm not very good at this. I need to be, but I'm not. And so this is the line that represents the equation y equals negative 1/3 x plus 3. Let me clean that up. I'm really struggling here, aren't I? Y equals negative 1/3 x plus 3. This is the name for that line. And like we said before, everything on the line, not just these 5 points, but everything on the line is going to be a solution. Everything extending this way forever, and everything extending this way forever. If you've got the coordinates for those points and plugged them in here, then they would create truth. Anything off here, anything, even these. When you take these coordinates and plug them in here, they will not create truth. Test out this 3, negative 1. Put a 3 in here. 3 times negative 1/3 is a negative 1. Negative 1 plus 3 is a 2, but we should have come up with a negative 1. That doesn't create truth. So everything on this red line does not create truth for this one. Everything on the blue line does not create truth for that one. And we're all about truth. And notice this did, in fact, take this one and shift it up 3. We took this one that was a 2, shifted it up 3 to 5. Took this one that had a y coordinate of 1, shifted it up 3 to a 4. Took this one that had a y coordinate of 3, this one that had a y coordinate of 0, shifted it up to 3. This one had a y coordinate of negative 1, shifted it up 3 to 2, and took this one that had a y coordinate of negative 2, shifted it up 3 to 1. So what we're noticing is when we have linear equations in 2 variables, every variable is to the first power. No variables are multiplied together. Didn't see that in any of this. The graph is going to be a straight line. The graph on each of these, when it's to the first power, the graph is going to be a straight line. And notice that this equation, y equals mx plus, that's a b right there. That's very similar to this one. Notice the difference between this and this is only this right here. And so if that b is positive, it will shift everything up that many units. If your b is negative, it will shift everything down that many units. So meaning it will take this graph here and shift it up that many units if b is positive. We'll take this graph here, shift it down that many units if b is negative. So that kind of helps with the graphing. But the bottom line is this. If you need to graph any of these, easiest way to do it is that point plotting method. Now granted, this is kind of long. It's a little tedious. It's tedious to make that chart. But it's a tried and true method. It always works. And there's some other shortcuts that I'm going to show you in further videos. But if you forget those shortcuts, this always works. And nobody ever forgets the point plotting method because all it does is it says, hey, pick some values for x. Do the order of operations. Spit that y value out. Creates an ordered pair. You know how to put an ordered pair on the graph and connect the dots, and that will give you the graph for that equation. So now we're going to take a look at an application of this. Where does this help, this point plotting method, and where can we use this in real life? And I'm going to show you an example of that. Okay, so here's the application. A frostbite victim's temperature, oh, that should be victims, plural. I mean, not plural, but possessive. A frostbite victim's temperature was 11 degrees below normal, but it increased by 2 degrees per hour. We want to let T represent the amount that the temperature is below normal, and we want to let H represent the hours that have passed. We want to write an equation that represents this relationship, and we want to graph that relationship. Now remember, I've told you before that when it comes to word problems, you need to read it in its entirety one time just to get a feeling for what's happening, then take it very slowly, sentence by sentence. So the feeling that's happening is we've got that temperature that's below normal, and it's increasing. Now what does increase mean? Yes, we are adding to that temperature. So we have that initial temperature, initial temp, and we are going to add to that certain degrees, and that will give us that temperature at that point in time. So this is the feeling for what's happening. Now let's go fill in those blanks. The frostbite victim's temperature was 11 degrees below normal. That's where it started. That's that initial temp. But how do we represent 11 degrees below normal? Absolutely, that's going to be a negative 11. Now what we're going to do is it says it's increasing 2 degrees each and every hour. So we're going to add to that 2 degrees, but this is going to keep on happening. We're not just adding 2 degrees and stopping. This is going to continue on for 1 hour, 2 hours, 3 hours, and 4 hours. So in the first hour, we're going to add 2. In the second hour, we're going to add another 2. In the third hour, we're going to add another 2. So we're just going to continue to add 2, 2, 2, 2, 2. What would be faster than repeatedly adding 2? Yes, multiplying by 2. Because repeated addition means multiplication. So we're going to multiply by 2, but what are we multiplying to 2? Yes, the number of hours, because we're saying in the first hour add 2, in the second hour add 2, in the third hour add 2. So we're going to take the number of hours and multiply that to 2. We said let H represent the number of hours that have passed. So we said what we're going to do is we're going to take these number of hours, H, we're going to multiply it by 2, and that's what's being added to that initial temperature. So we start at negative 11, we're going to add a 2H to that. In the end, that will give us that temperature, so that's going to be the temperature, that the T, the amount that the temperature is. So now we have our equation. We did the hard part, writing the equation. Now we need to graph it. And this is what we discovered in that point plotting method, that we can take this and we can make that chart. Now in the chart we had an X and we had a Y, but here we don't have X's and Y's. Instead of an X, we have an H. So let's just call it an H instead. We're going to take our values that we choose for H, we're going to plug them in here, and that's going to spit out T values. We used to get ordered pairs, so now instead of an XY, we get an HT. But that ought to do it. Now before we had said pick any values that you want, and remember we said when it came time to graph this, we were going to put it on this 2D coordinate plane that we see right here. But notice that on that 2D coordinate plane, this is going to represent no longer the X, it represents the H. And we said pick a couple of positives, a couple of negatives, and pick that 0. But let's think about what's happening here. H represents what? Yeah, it represents hours. So in this graph, what doesn't make any sense? You're right. Negative hours makes no sense at all. So I'm not going to have this end of the graph. I'm only going to have this end of the graph. Now let's consider something else. This represents T. So can we have positive temperature? Yes. Can we have negative temperature? Well, yeah, because we're starting at negative 11. So this is what our graph is going to look like. So let me fix this up a little bit here. And our graph is now, here's our T, here is our H for hours, and it can extend into the negatives. So now let's test a few points, knowing that we're going to pick values for H, but this time we're not going to pick any negatives. So I'm going to start with the 0. I'm going to go with 1 hour, 2 hour, 3 hour, 4 hour, and that ought to be enough for me to get a picture of what's happening here. Because since both of these are to the first power, I know that this is going to be a straight line. So honestly, it only takes 2 points to make a line. I only really need 2 of those, but I'm going to go ahead and use the others just to kind of calibrate it and make sure my line is going the way it should. So I'm going to plug that 0 in for the H. Follow those order of operations. It says multiply first. 2 times 0 is 0, plus that negative 11 is a negative 11. Meaning that at time 0, I'm going to have, or the victim is going to have a temperature of negative 11, which makes sense because it says the temperature starts at negative 11. Now I'm going to say, okay, let's make the hour 1 hour. What's the temperature now? 2 times 1 is 2, plus a negative 11 is a negative 9. Which says after 1 hour, the temperature is now a negative 9. And that does make sense because we're adding 2 degrees every time. Add a 2 to a negative 11, you do get a negative 9. Now, let's say, okay, after 2 hours, what's happening? Well, it stands to reason we should get a negative 7, but 2 times 2 is 4. Negative 11 plus 4 is a negative 7. So sure enough, after 2 hours, we got a temperature of negative 7. So here again, it stands to reason that this one should be a negative 5, but let's test it out. 2 times 3 is 6, negative 11 plus 6, yep, it's a negative 5. So after 3 hours, the temperature is a negative 5. All right, let's keep on going. Let's test out that 4. And so 2 times 4 is 8, negative 11 plus 8 is a negative 3. Yep, that works. Because if we take that negative 5 and add 2, we get a negative 3. Now we're going to put all these on that graph. So notice that when my hours are 1, 2, 3, 4, now we'll go ahead and put the 5 on there. But when I have 0 hours, my temperature is negative 11. So let's put We've got a -1, -2, -3, -4, -5, -6, -7, -8, -9, -2. Whoa, -11's right down there. I did not do a good job, but that's okay. 0, -11 is going to sit right down here. And 1, -9 is going to sit right here. And 2, -7 is going to sit right here. And 3, -5 is going to sit right here. And 4, -3 is going to sit right here. And I'm going to connect them, and it's going to go like this. Now, notice in this, normally I would put an arrow down here and an arrow up here as well, meaning it's going to go on forever. But this time I only put an arrow up here. Why did I not put an arrow down there? You're right, because it would indicate it goes forever this way. Is it going to go forever that way? No, and why not? Because that would indicate negative hours. And we know we can't have negative hours. We know we begin time here at 0 hours. The temperature will continue to rise. Now, technically, this says it's going to continue to rise forever. No, the temperature's not going to rise forever. It's going to level out at some point. But for our purposes in this graph, I'm going to put an arrow to say, keep on going. It's not stopping right there. And remember, every point on this graph is a solution, even the ones in between. These are just marking off full hours. If I wanted to go with a half an hour, that would be this point right here, which would actually be a -10. If I wanted to go for like 3.5 hours, that would be this point right here, which would be a -4. So everything in between works. What doesn't work is everything out here. None of these combinations will work. 1 hour, 1 degree doesn't work at all. Because if you put a 1 in here, 2 times 1 is 2. And 2 plus a -11, well, we had a -9. So if we get 1, 1, that temperature of 1 degree is not going to work. So everything over here doesn't work, everything down here doesn't work. And the nice thing about the graph is we get a picture snapshot. If we say, okay, in 10 hours, what should that temperature be? Well, if we extended this out, we would go to 10 hours, we'd go up to the graph, and we'd say, oh, that t-value is, at 10 hours, that t-value ought to be 9 degrees. And so we can just at a glance figure out what that temperature is going to be. So hopefully this helps you to see some of the applications for graphing these equations so that we get nice picture representations of what's going to happen. The picture representations really give us a visual that we can kind of sink our teeth into. So I hope that you understand the point plotting method. Again, like I said, not a difficult method, just kind of a long and tedious method, but a pretty easy method to work with. I hope that helps. Have a great day.